Hi people, this is the video tutorial for homework number 5, lab 54. Now, the homework for lab 54 is pretty much the same as the lab 53. The only difference is that for you guys, 54, I'm going to collect problem number 2. For the people in lab 53, they have to turn in problem number 1. Okay? I already made a video for people in 53 who wanted to see how number 1 is done. So if you want to watch it, if you want to see how this is done, you should go to the lab video tutorial. Okay. For you guys, I'm going to be solving this problem. Now, what we have here is okay. As soon as you see this, you have to understand that this needs to be done with hybrid elements. In other words, do not go and create an object like that and then measure it with solid elements. There's going to be substantial reduction of points, deduction of points if you do it with all solid elements, substantial. Okay. Now, what you should realize is that this probably should be done with shell elements because the thickness is relatively small. Okay. And these dimensions are big. And then these should be done with beam elements. Okay. Now you might say, okay, I don't know, this is kind of bulky. All right, well, okay, so look at this. I could have drawn this thing. I could have drawn these things, looked a lot thinner and a lot slimmer, but, it should not fool you. You really have to look at the numbers and relative sizes of these things. Okay. Now, the other thing is that you're asked to use as many planes of symmetry as possible. So if you look at this, clamp, these are perfectly welded together, okay? And then this is subject to a pressure of, maybe because of the wind or whatever, 30 psi, okay? Now, obviously, this is a vertical plane of symmetry, so you have two choices. Make the whole thing, cut it into half, or actually make half of it. We want to make half of it. That's up to you. The other thing is that all the problems that I've done for you in the class and these other tutorials, I tried it, or at least in class, let's say, we tried it as one part. I made one part, which has this plate in it and this line in it, okay? So the first time I'm going to do this for you in this video is doing it as a single part. Then I'm going to come back and do it as an assembly of a part which is a plate and a part this is a line. Okay, for now, I'm going to make it a single part. Now, let me, I need these dimensions in front of me, so I have to look at my other computer for a second. Just 1 second, please. Okay, very good. All right, so we go here. This is all made out of steel, by the way. You go here. First one is a single part. And remember, I can give it any name that I want here. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's your student ID number. Your last name is Tsai Wu, Tsaiwu. Stephen Tsai was a professor at Stanford University and working at the U.S. Air Force research facilities. These guys are very famous in composites. So we're going to do this thing. I'll call it problem 2. How about that? Single part, obviously, and it's going to be problem 2, right? Problem 2. You say okay. Notice that this name appears here, and you can save it right away. So you go File, Save Management, Save As, a folder on the desktop, a new folder, and we're going to call this thing Lab 54. We're going to do it as a single part, okay? Single part. Okay, very good. Say okay. All right, let's make it. Why don't we make that? Plate first? So on this plane, I will sketch half of that plate, which okay. So I'll draw a rectangle like this, yeah, like that. Okay, half of the length is 4 inches. This is 4, and this is 3. Okay, and the exit. Now I want to put a surface here, so I can use fill right there, fill. Or I could have drawn a line and extruded it, but the way I did it, you just fill it. There we are. Okay. Then we're going to do the leg of the, we're going to do the line here, which represents the right leg. And there are different ways of doing it. One way is to create a line based on this point and a direction. Okay. The other one is create a point here, create a point here, connect them with a line. So I'm going to do that point and direction. So a line based on a point and direction. I select this point, and the direction is about the z-axis. Okay, and you put, I don't know, if you look at from that bottom, it's going to be 10 inches down. So 10 inches down. Let's see how it looks like. Okay, so put a -10. There. Okay, very good. This is it. This is my model. Let's make everything out of steel. So apply material on that part. Everything out of steel. You say okay, and this is it. Save it. Now we're going to go to generative structure analysis. Please make sure you watch the videos for for the other section. Make sure you know how to do problem 1, and watch the videos for labs 51 and 52. They're different problems, so this gives you multitude of opportunities in order to practice these things. Okay, good. Now some of the stuff that I don't want, I can hide. Like this sketch, I don't want. I'm going to hide it. Okay, I'm going to change the rendering to rendering like that. I don't have, in this particular problem, I don't have solid elements. In the first problem, I do have a solid object. Okay, not here though. Okay, so let's see now. We have to measure. Okay, so we're going to mesh this thing with shell elements. Where is the measure? Right there. Shell elements right there. You select this. Okay, we'll keep that size the same. Okay, give it a thickness. 2D property right there. You select that. Now 0.25 is from the previous problem, so let's see what this problem is. It says thickness. No, that's thickness of this thing. I think I forgot to write the thickness here. I forgot to write the thickness. So I'm going to revise this your homework 53 and 54 so that the thickness is specified. The plate thickness is 0.25 inches. That's something that was missing. Okay, I'll have to fix this. All right, so I'm too lazy. That's why I wanted to use the same number, 0.25. You say okay. Now we can mesh this this line with beam elements. Okay. Yeah, that's fine. So 1D property, you select that, and the radius of the cross section of that beam is oh, you know what? This thickness is here. This should have been, the plate thickness is 0.1. Okay, it's there, except that it's in a rather odd place here. So 0.1, I'm going to fix that. Okay, right here, thickness is 0.1. Very good. Okay, so we have it in two places right now. So I'm going to fix that. Don't worry about it. But the radius is 0.5. Radius of this beam is 0.5. So let's go back here. 0.5. Say okay. I just told you that there was a problem with this one. It should have been 0.1, 0.1. I thought the thickness was not there, but it was, and it was 0.1. Okay, now remember, if this was a sketch, you would have to join it before you can measure it, or you can actually, put properties on it. But this was a line in space. That's why I did not have to do that. Okay, so let's go ahead and save this. File, save management, the analysis, save as in that folder. Lab 54, single part. Let's clean this up now. Your student ID number 1, 2, 3, 4, 5, 6, 7, 8, 9. Last name Sai Wu. Sai and Wu. These are two different people. And this was a single part, right? Single part. Single part. And problem 2, right? Problem 2. Problem 2. Okay, very good. Say okay. And say okay. Excellent. Now, this bottom is clamped, so we clamp it. This edge of the shell, remember we modeled only half of it, lies in the XZ plane. So, I say XZ plane, XZ plane. Therefore, XZ symmetry, how about that? Symmetry. XZ plane does not move in Y. If it's in XZ plane, does not move in Y, and rotations are opposite. See, does not move in Y, but rotation about Y is free. And that edge, right there, okay. And then we apply pressure. Pressure is pressure. Don't divide it by 2, don't multiply it by 2. So 30 psi into this. So make this thing 30. And you can see what happens. It's actually right there. It's if you want it to come out the other way around, okay, double click on it, put a minus. It really doesn't matter. It pushes it one way or the other. It's the same problem, okay? Now, if I run this thing, it will bomb out because this plate has no idea that there is a beam attached to it. Just to convince you, let me run it and convince you that it's going to bomb out. Right there. And if I say, show me the deformation, you can see it's going to move out. Okay, now, when you have, the problem says these are perfectly welded together. So first of all, let me get out of this, deactivate that. So you need to create a connection. Connection. Let me hide the surface. The end of this rod is that point. And for the second one, second component, bring the plate in the show mode, hide the rod or the beam, and hide this connection right there. So, and this is going to be rigid. It is tempting to say point to point fasten. It does not take it. CATIA does not take point to point as fasten. Okay, you have to do it as rigid. So rigid, the one that you just created right there, and you say okay. Now, in your problem is simpler than problem 1. Okay, problem 1 has another connection that you have to create, a fasten connection, not yours. Please, if you need practice, look at their problem, look at the problems for labs 51 and 52. Okay, so I think we got everything worked out, so let's run it and pray. First of all, deformation. Let's change the scale here so that we can see it. There we are. This is a flimsy sign. Now, That doesn't, by the way, surprise you, because if you had a bar like that and a highway sign, although this is a model sign, you would not just weld it here. You probably will weld it here. In fact, you will weld this edge. You take the edge all the way up, and you weld that edge to that plate. Now, I didn't do that. Okay, so what I'm saying is that you can try by yourself. See if this line went all the way up there, and then you create a connection between that line and the edge, either the edge of that plate or the surface of that plate, and make that fastened, not rigid, fastened, and it's going to look a lot better. Now, by the way, the view from the front, it tells you that symmetry is maintained. You see that? It doesn't go to the left or it doesn't go to the right. Okay, you can look at the stresses. Of course, there's going to be gigantic stress here probably because of the connection. You can see that. Now, you can't see the 1 meter stress for the beam. You know that we can't get it. So, and we have absolutely no confidence in these numbers. I mean, that's 1 million psi. That's nuke, basically nuking that steel part. Okay. The moral of the story is that I show you how to do these. When you get paid, you better do a mesh conversion study and work out something that makes sense. We have no confidence. We know how it works. We know how to do the problem. Not relying on these numbers, though. All right, so I'm going to repeat this problem this time as an assembly. Okay, so let me close this and close that. By the way, if you had to submit this problem, this was lab 54, right? Single part. You give us the part, single part, and the analysis, both of them. It goes into the folder or the menu in your Blackboard says midterm, section 54. You go there. There's 3 problems. Problem 1 folder, problem 2 folder, problem 3 folder. These 2 go into problem 2 folder if this was problem number 2. Okay? All right. Now let's do that as an assembly. So we're going to start as an assembly, a product. Immediately, I'm going to rename this thing to have your naming convention. 1, 2, 3, 4, 5, 6, 7, 8, 9. Your name is Saiwu. Underscore. Now we're going to do this thing as an assembly. Okay, we're going to solve this problem as an assembly. And this is problem 2, right? Problem 2. We say okay. And we make it. Now, this is just naming it. I have to save it though. File, save management, save as, a folder on the desktop, a new folder. This time it says Lab 54. This is done as an assembly, right? Okay, so it's going to go there. We are good. Let's insert our first part. Insert, new part in there. And we're going to call this thing the plate. Right-click, properties. Right-click, properties. I'm going to call it 1, 2, 3, 4, 5, 6, 7, 8, 9. Saiwu. Underscore. This is a plate, the plate. And this is problem 2. Remember, we're doing an assembly. This is a part, but we're going to assembly problem. This is problem 2. I don't want you to confuse that assembly because this is a part we're doing, problem 2. Okay? And we do a copy paste here. Right click, copy, and part name. This was the instance name. Part name is right here. Paste. You see this? Now we're going to make it. Double click on it. You're going to go into generative shape design. Remember what we did? We created a rectangle here and we filled it. Let's follow the same step. Now we're making that part basically. So there we are. I think 4 by 3. 8. Yeah, 4 by 3. This was 4. This is 3. We say okay. Exit. and fill it, F-I-L-L, fill it with a surface. There we are. Now, if I go to top level assembly and click on the floppy, what's going to happen is that your product is going to be there and this part with that name is going to be there. Let's check it out. So it's right here, Lab 54 as an assembly. Notice that my product is there. There's your product, proper name. There's the part that you made, proper name, right? It says plate, yeah, plate. Okay. Now let's go and do the poll. How about the poll? Insert, new part. Say no. Let's call this thing the poll. Right click, properties. Okay, proper name. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Your name. Sorry, woo. Okay, so this is going to be the poll, right? And okay, if you want to add assembly to it, that's fine. I don't like it, but and this is problem 2. There's only 2 parts here, okay? For problem 1, there are 3 parts because there was also a block that I had to do. This is problem 2. Okay, copy. Go down here, paste. Okay, let's make it. There's not much to this. So, you know what? What I'm going to do is I'm going to pretend that the pole actually starts on the very top. How about doing it like that? In the previous one, I did it as a part. My pole started down here and go there. But now, for you, I'm going to show you what happens if the pole started on the top and goes down. That's a good idea, because remember, it was very flimsy down here. Okay? So, it's a bonus for you. Okay, so create a line starting on the point and direction, starting on the top. Please notice that I'm doing it differently for direction Z, minus 13, right? Minus 13. Yeah, so this pole starts on the top and it goes all the way to the bottom. Because I don't just want to weld it here. I want to make this thing fasten to that, okay? We're not solving the same problem, but I'm showing you as an assembly. That's okay. So let's go all the way on the top, make everything out of steel. By the way, I'm sure some of you are going to say, oh, what do we do on the test? How do we know that? Don't worry about it. If I needed that, I'll tell you. If I left it without saying either way, you get full mark, okay? All right, this is all done. So let's go ahead and we saved it, I think. Yep. Now we're going to go to generative structure analysis. There's no solid part, so CATIA doesn't mesh anything. We have to do it ourselves. So we go to shell mesh, that surface. Yeah, I'll use the same thing. Okay. Thickness, 0.1. Remember, I thought I was missing, but it was 0.1. Okay, very good. Now the beam measure, that entire thing from the top to the bottom. I'll use the same thing. That's fine. And 1D property is the same as before. There's the support. And this is the cross section. Okay, very good. Correct radius. That's still, yeah, exactly what the problem told me. Let's save it. File, save management. There's my analysis. Save as in that folder. This is assembly folder. Put the correct name. 1, 2, 3, 4, 5, 6, 7, 8, 9. Dash. Sorry, woo. This is assembly, right? I'm solving an assembly so that I remember. And this is problem 2. Problem 2. Okay. There we are. Okay, let's clamp the bottom. This bottom is clamped. Very good. Let me hide this sketch here. I don't want to see this sketch. Okay. Change the rendering if you feel better. These colors hurt my eyes. Okay. Now, this is subject to pressure of 30 psi. So let's do 30 psi here. or negative 30, whatever it is. It's pushing it. Yep, that way. Very good. Now, symmetry. This is symmetry, right? Same thing as before. In fact, it's the same checkboxes, because this edge lies in the XZ plane, does not move in Y, rotation is opposite. Now create a connection. We create a connection between the different ways you can do that. You can do it between this beam and for the second component, that plate, or the edge of the plate. I'll use the same. Okay, we save it. Now we have to declare what kind of a connection. This connection, we pretend that these are welded together, so we make it fastened, perfectly welded. You cannot weld a point to a point, a vertex to a vertex, but you can do edge to edge, edge to face, face to face, etc. So where is that fasten thingy? Right there. It's a face-to-face connection. It's that guy. It puts the fastener sign right there. You see this? Right there. Okay, save it and run it. I think the result here probably will be better. It's not flimsy because these are welded at that point. I mean, obviously it caused a problem. So run it and look at the deflection. Okay, so deflection, this is more reasonable, you see? So look, when it comes to marking your tests, we don't care unless we told you that. But for real life, this makes more sense. You don't weld that bar to that plate at that location. Maybe you weld it all the way to the top. Okay, that makes sense, but not the way we did it initially. Okay, and of course you can look at the deflection, 0.2 inches. Okay, that's fine. And the colors and all these things. Color is easy. That's the least of our problems. We can generate good-looking garbage, good-looking colors. Biggest deflection is here. And you can look at the von Mises stress, okay? So, yeah, I mean, I have no confidence in these things, but if I do a mesh convergence study and look at it more closely, then I can say something. Now, let's save this, because I want to show you if you did it this way, and it's entirely up to you. Do it as a part or do it as an assembly. What is it that you have to submit? You have to submit your product. You have to submit the two parts. Remember, there was a pole and the plate. And you have to give us the analysis. All four of them. Any one of them missing, we cannot assess your work. And you're going to be in trouble. You're going to be upset. We're going to be upset. So, yep. Please watch the other videos for labs 51, 52, and 53.